Hi guys, so for the next few nights we'll be talking about how to use your nSpire well to help you with some skills that you may or may not have already known will happen on the nSpire to help you just save some time and to check your work. Please keep in mind, anytime you have a problem to do, whether it's in my class or on a Regents exam or anything in between, you do need to show work. However, these are great ways of checking. And it's one of those things, if you've never been good with fractions, learn how to use your fraction button and things like that. So that's our next 3 nights of lessons is nSpire use. Tonight we're going to focus on the calculator pages and the graph pages. You've seen much of those before, so it'll be a real quick overview and maybe a couple of surprises thrown in. So what I'd like you to do on your calculator at home is start a new document. And we'll start with our calculator app. And so here I have a blank page. Remember that your menu will do a lot of things for you. It can, when you have many things in your scratch pad, it can clear the history, or it can clear the history of your calculator page. I don't really suggest that because often we want to copy paste. If you've stored variables, you can clear those. I wouldn't do that until I was at the very end of a document and making sure I didn't need it anymore. In my number menu, I can convert from decimals to fractions and fractions to decimals. I can even do some basic number factoring. I cannot do algebra factoring. These calculators are not algebra calculators. Some of these things, again, we'll use now, some we'll use later. In algebra, there's numerical solve, there's solving systems of linear equations, which I'll show you real soon. We are not, let me escape out of that. In a calculus class, you don't need that. We will do some probability later on, some statistics later on. That's actually the next 2 nights worth of lessons. And the rest of this we won't use, except for functions and programs on our problem-solving Mondays. So let's get out of these by escaping. And just some quick reminders in your calculator page. Let's say I can't remember for the life of me how to add my fractions and I don't want to spend time doing it. Remember your fraction template is control divide. And then you can type in any old fraction. We can add whatever you want. And fractions stay fractions, and I much prefer that. Most of the time, I want your fractions to stay put. If for some reason you're asked to round in a problem, say for the Regents exam, there are a couple things you can do. Please remember your copy-paste option. So I want to copy that 32/21 down, so I'll arrow up until it's blue, press enter to copy-paste it. If I put a decimal after either of those numbers, it converts to decimal for me. If I don't like that, and I want to move my decimal to the denominator, it will convert for me still. Some people prefer to use the control enter because that symbol's approximately, and it does the same thing. You're getting the same answers. There's 3 to 5 ways to do anything on this nSpire. If you copy that final answer down, it will show it to you less rounded, and that's a good idea. So the other thing I want to show you, a button that people tend to forget about is this button next to 9, and that is a menu of all kinds of symbols that we'll use. The most frequent ones, again, are fraction, but we use that with control divide. Absolute value we'll use quite often. You can get to your exponents and roots here. And we can do some matrix work and some other stuff. Anything with these T's, you can't do. Those are for a CAS calculator, a computer calculator, and this is not one of them. So let's say I want to take the absolute value of -3. It's just a reminder that that is 3. Solving systems, something I want to show you. If you go back to menu and you go to algebra, and choice 2 is solve system of linear equations. If we have 2 equations and my variables are x, y, that's all set up for you. You can choose OK. And notice it says linear solve, and you have 2 places in which to solve those equations. So you can type in some system. Whoops. Oops, I lost my X there. And press enter, and there are my solutions. Again, when you solve systems, you have to show all the work on your paper, but this is a wonderful check. If you get some crazy answers that look like that, you really want to check and see that those are appropriately crazy answers, and in this case, they are. Another big thing that I want you to be able to do is not make mistakes with PEMDAS. PEMDAS just really messes people up. If you learn to store variables, values in your variables, then you'll never make PEMDAS mistakes. So for example, let's say I ask you to evaluate a function when x is -2. So I'm going to say x, control the button next to 9, that's your store in variable, -2. So I've stored -2 in x. Now I want to evaluate x squared plus 4x minus 7. Notice the x is bold. It's telling you that something's stored in there. And the value of that function when x is -2 is -11. Sometimes you'll wonder if it actually is -11. You're going to check, kind of like, is this point on the line? You could substitute your x and y and then plug in the equation. I could have typed something like x squared plus 4x minus 7 and use this equal to button. That's a check if it is it equal to -11, and I get the word true. If it was wrong, say I think it's equal to 10, I get the word false. So we can always check our work using the store function on our calculator. Another great function that I want you to get really good at, store variables a lot. Something else I'd like you to see in your menu, again for checking purposes only, you have to show me all your work, is in menu, if you go back to algebra and go to numerical solve, it says nSolve. You can type in an equation to solve. Let's say 3x plus 4 equals 5x minus 6. You then say comma x. You have to tell the computer that you're solving for x. It solves that equation for you. X equals 5. I might want to check that. I'm going to store 5 in x. And then I'm going to type my equation, 3x plus 4 equals 5x minus 6. And we better hope it solved it correctly, and it did. So that's another really nice checking feature. You still have to show all your work. Just use your nSpire to check. Be careful with quadratics. Solve that. Notice it only gives me one root. It won't give you both roots. So sometimes it gives you the negative root, sometimes it gives you the positive root, sometimes it gives you the smaller root, sometimes it gives you the bigger root. So that's not a perfect way to solve quadratics, but it's a start for checking one of your roots. If you go back to menu, algebra, polynomial tools, you can find roots of a polynomial. You need to know that a quadratic is a degree 2, the highest exponent. Right now our roots will be real. And notice we've got a polynomial in ax squared plus bx plus c form. So let's say I was solving x squared minus 4. So my coefficient on x squared is 1. I had no b term, so that's 0. My c term is -4. There's that same equation. There are both of my roots. So if you want to solve a quadratic or higher, which we'll do later in the year, you can use polynomial roots. So those are the highlights of your calculator app. There's many more highlights, but those that we'll learn through the year, but those are the big ones right now. So let's add a graphs page. Control Doc, add a graphs page. And again, you've seen a lot of these things before when we reviewed our quadratics, but just a quick review of some things. Maybe I want to graph the absolute value of x. That's an old friend from algebra class. Choose that absolute value template. And there's a reminder of our v, and we'll do much more with this in the next unit. I'm going to tab and up arrow and graph something different. Maybe I want to graph something more fun, like 2x cubed to the third, get out of that exponent, plus 5x squared minus 7. Well, we'll say -3 so you can see the y-intercept of -3. So there's a really interesting looking graph. I have my y-intercept of -3 for my constant, and I have 1, 2, 3 zeros, highest exponent's 3. Just like we did with quadratics, you can menu, analyze, zeros. You go to the left, you go to the right, and there's the first one, and you would repeat for the other zeros. Just like with our quadratics, you can analyze minimums. This is what we call a local minimum, that little dip. There it is, 0, -3. We could analyze our local maximum, that local peak. Menu, analyze maximum. And there's that maximum point. Let's say I'm solving a system with this x cubed function and a linear function. So let's tab to get a second function in, and we'll just do y equals x. There's that line. I see 1, 2, 3 points of intersection. Those would be my solutions. So I'll menu, analyze, intersection points. Same thing. Whoops. Don't grab your paper and move it. Go lower bound, upper bound, there's an intersection point, so there's an xy solution. Now notice x equals y, so all of your points will be the same, x and y. And maybe we do that again. Menu, analyze, intersection. So you can solve any system by graphing. Your solutions are the points of intersection. Sometimes you have to grab points and move them out of the way because graphs get messy. Something that I'm really bad at, that Mrs. Casey is very good at, is getting a grid on your graph paper. Make sure you say menu, view, grid, and you want a lined grid. And that really helps you, especially when you have to transfer to graph paper. Don't forget again, we've done this before. Don't forget again, Control-T gets you a table if you need to plot some points. In a document, Control-6 separates that onto its own page so that it's easier to read. And for now, that's really all you need to know about your graphs. If we look at the menu, notice it's different for graphs. Again, if you need to get rid of everything, that's under actions. If you want to start fresh, you would delete all. I'm not going to do that. Make sure right now you're always in function. Sometimes some of you have seen weird stuff pop up. That's why you weren't necessarily in function mode. You can change your window here with window zoom, but I tend to prefer to click a reasonable point and just edit there and tab around until you see as much of the graph as you think is necessary. Okay. And that stretches out the graph to see some more features. It also, in my world, this graph paper starts to look messy, and that's why I tend to forget the grid. But if you prefer the grid, that's just fine. We can add some geometry things, but we won't do that anytime soon. We do avoid trace. It's not always perfect. There will be uses for those eventually, but we don't trace much. Instead, we use our analyze functions, and we analyze zeros, minimums, maximums, or intersections. The rest of this is calculus, and till later on we'll talk about some conics things. So that's really it. Those are highlights of what I need you to be able to do on your calculator, on a calculator and a graphs page. Tomorrow and the next day we'll do more with statistics. Have a good night.